Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Now, this is a fun episode. For longtime listeners of the podcast, you'll know my co-host from seasons 1 to 4, Julia Schottenstein. Julia sadly left me to join LangChain as an early employee. And while I don't actually know what her job title is, my understanding is that Harrison, the CEO, asked her to basically solve all of the problems that aren't specifically in product and engineering. LangChain, of course, has become one of, if not the primary framework for developing applications using large language models. There are over 1 million developers using LangChain today, building everything from prototypes to production AI applications. In this conversation, Julia and I go deep into the world of LLMs. Julia's brain moves incredibly quickly. So over the course of the conversation, we covered a huge amount of ground. If you're looking for a comprehensive overview on the state of the AI ecosystem today, this will be an hour well spent. Without further ado, let's get into it. Julia Schottenstein, welcome to the Analytics Engineering Podcast.
Good to be back.
Before we dive into it, for any subscribers who have started with us in the past, season, can you just say hi and give a little bit of context on why you and I will probably have a little bit of fun with this episode?
For those who don't know me, Tristan and I go way back. We started the show together back at DBT Labs, when I was there for many years, when it was Fishtown Analytics, and then became the great DBT Labs that it is today. And I'm definitely rusty because it's been a year since I've been on the podcast, but I'm now at LangChain, which is a small startup in the generative AI space. And I'm sure we'll be talking about a lot of fun overlap between the data world and the Gen AI world. And hopefully you all will enjoy the conversation too.
A small startup. That's two interesting words. LangChain has an outsized impact for being a small number of humans. Before we dive in, I do want to say for everyone listening in that I am an investor in LangChain, very, very small, but I don't think there's any like weird conflicts or anything like that. I'm mostly just enjoying learning alongside everybody else here. You said small startup in the generative AI space. I think that maybe we could scratch 2 levels deeper. What is LangChain, and what kind of impact is it having in the space?
So 2 co-founders, Harrison and Ankush, got started on LangChain. It's an open source project back at the end of 2022, so right before ChatGPT became a enormous household name. And what LangChain did was give you building blocks so that you can build your own applications much more easily. So simply, it's a framework that can be used in Python or TypeScript, and it helps you bring your company or your personal information, your APIs, or up-to-date information to the context of the LLM reasoning API, so it can do more useful things. So as listeners probably know, LLMs can do a lot. They've been trained on an enormous corpus of information, but they have no idea about your private data or your private information. And so to do useful things for your business or for your personal use, you have to prompt the LLM in very specific ways. And what LangChain does is it helps bring that kind of pipeline of data and computation to the LLM, so you can build apps and do things like customer support bots, or you can have personal assistants, co-pilots, things of that nature.
So we've certainly talked about RAG, retrieval augmented generation, on the podcast before. Is LangChain exclusively used in RAG workflows, or is it also relevant for kind of fine-tuning workflows?
Yeah, so RAG is very common. What people use LangChain for, it's probably the easiest way to think about it. It's an orchestration framework. So you can do simple things like chain together a bunch of LLM prompts. You can retrieve information and augment the generation from the LLM, which is called RAG. But fine tuning is kind of related. Fine tuning is specifically when you take your LLM or your model and you give it some extra information about your specific context, so it can generate responses bespoke to your use case. And so lots of people use fine tuning in conjunction with RAG, or they use fine tuning in conjunction with agentic workflows. But it's all the above. We're a orchestration framework for building with LLMs.
Okay, so LangChain can help with fine tuning workflows as well.
More that fine tuned models are an input to
Got it.
the
Okay,
to the overall application logic.
that makes sense. I often think, and this is a lossy analogy, but I often think about LangChain as the DBT for AI.
I think about it the same.
Yeah, the reason that I think about it like this is that DBT said, okay, there's this fundamentally new compute construct, the cloud data platform, and it needs a programming framework on top of it to enable users to do the things that they want to do that are unlocked with this new compute substrate. And LangChain certainly doesn't do the same stuff that DBT does, but I think it came out of that same kind of need. Hey, there's a new kind of fundamental compute construct, the large language model. What are the things that you need to do in order to make that useful? And it feels like the origin story is a little bit similar too. Harrison really started building for himself, is my understanding. Can you comment on any of that? Like, how much of this do I have right?
Yeah, obviously, I have the same similar biases to you, having been a part of the DBT journey. But I think it's pretty similar in the sense that uh, LangChain has become a way for people to learn about generative AI and how to build applications. And so there are these common building blocks, just like you have with DBT. You have your models, your tests, you have documentation, all of these components, a recipe in order to do this work. Pretty similarly with LangChain, we have all of the components that you would need to build an LLM application, and they're pretty simple. A lot of times, it's a prompt plus a chat model plus an output parser that takes kind of raw text, makes it structured so it can be useful in kind of downstream workflows. But it's a framework, so it's open source. There's a big ecosystem around it. I think we have 1 million developers now who use LangChain, and similarly, our partner ecosystems really important for making LangChain as special as it is. And so there's the vector databases, which there's dozens of those, hundreds of different models, and people will swap in and out these components as they need. And a big benefit is you can define your logic once for your application logic, and then we've abstracted away a lot of the commonality amongst the underlying technologies, mainly the LLM and vector database.
So you could, in the same way that if you want to for a second forget about some of the intricacies of the different SQL dialects on the different platforms, you can take your DBT code and run it against one data platform and then point it to another data platform, and most of it will just work. LangChain allows you to do
Same
similar
concept.
things. Yeah.
Yeah.
Okay.
Yeah. And it's really common, especially for at the model layer. People will often start with the high powered model to see if it can work, get their application working in a proof of concept. When you have to scale it, you have other considerations around latency and cost. And maybe you want to start dissecting the problem space into models that fit your needs better. And so swapping out your models, changing your prompts, tailoring them to those specific models is a really common pattern. And you don't have to start from scratch because you have the Legos in LangChain.
How does the OSS work? Who writes the code? Is most of the open source code like the integrations that we're talking about between all these different components? Do the vendors of the different systems own their own integrations? How does it all work?
Yeah, so it's evolved quite a bit. Initially, we had this like mono repo where all the logic was in the same code base, and
Okay,
is you.
I remember talking to Harrison during this, and he's just like, "Holy shit! I have 250 pull requests to approve like
Yeah,
tomorrow."
yeah. Sneak peek that didn't slow down. Just the problem just gets worse as you get bigger. You have more issues, more bugs, more pull requests to deal with. But one of the things I think we figured out was what is the core part of LangChain that we at LangChain need to own, and so we put that in its own repository, LangChain Core, mostly maintained by us, and it's really the runtime. It does nice things like handles fallbacks, retries, does important things around token by token streaming, standardizes like output parsers. And so that logic is all LinkedIn core. And then there's just an enormous long tail of integrations. And I think we have over nearly 3,000 contributors that contribute to the integrations. And I think, there's dozens of people at Google spending time on the LangChain ecosystem to make sure that all the Vertex models are uh, supported well in LangChain, and you can go down the list, and that's true of all the big players because many people
Because
start with
LangChain
LangChain. Yeah.
drives usage for these
Yep.
platforms.
Mhm.
Yeah. In the same way that DBT does for the data platforms. This is all very interesting. It's an interesting point to sit at in the ecosystem as this kind of programming framework that abstracts away a lot of these details and allows developers to work more efficiently and all of this. It also, I think, as you will take with you from your days at DBT Labs, it's not always easy to monetize that particular junction point of the ecosystem. There's a lot of tremendous amount of value in being open and open source,
Mhm.
but then you have to figure out, okay, where do you actually make money? You folks have made some progress on that over the past whatever year. Can you share that?
Yeah. So a strong commitment to open source because it's where people build their application logic. You similar to languages aren't proprietary, frameworks shouldn't be proprietary. Open is how it all works, and the ecosystem wouldn't invest as much if it weren't open. So LangChain and LangGraph, which we might get into later, these are orchestration frameworks that are open source, MIT license. LangSmith is our commercial offering, and it's a companion product. And the reality with all LLM applications, the hardest part is quality. So really easy to get a proof of concept built in sometimes an afternoon. Uh, Getting it to work consistently well at scale and not have embarrassing moments when it's in production, really hard. A lot of engineering work goes into polishing those rough edges and making it worthy of end users or end customers to interact with it. And so LangSmith helps solve that problem. It really is around testing and observability. Can give you a set of tools such that when you're going from prototype through to production, you can experiment with changing logic, see how that impacts metrics you care about. Once it's live, it's a monitoring and observability platform, so you know what are people asking of your application, how well is it responding to questions. You can categorize topics well so that you can do useful data work and improve your application. And so LangSmith is full proprietary and really supports you in making your application higher quality, getting to production faster, and giving you visibility you need once it's live.
It feels very reasonable. At the same time, like I don't know what any of that means yet. And I wonder if the industry knows what it means to like test or
Mhm.
observe an LLM application. Like we, software engineers have been testing and observing classic software applications for forever, and I feel like we're trying to invent the tools and processes that we need to make our AI applications high quality, like on the fly. Like,
Yeah,
do you know yet
totally.
enough about what your users need to do this in order to build what they need?
Yeah, no, I mean we're definitely learning as we go, and I think Harrison puts it well. Like the big advantage of being open source is that we get to learn from the teams around the world who are cutting edge, and we can build alongside them. And so a big advantage of open source is not just all the classical things that you would think as distribution benefits and being able to build forth a big community. But we get to learn alongside hundreds of teams as they're putting things into production, and then we respond to all the friction points, all the pain points, and try our best to move quickly to build product to help solve it. But it is an evolving practice, and we do wonky things in the LLM app world where you use an LLM as a judge, which is LLM as judge is this like common technology or common industry term where to run your tests, you just ask another LLM how to do. And that kind of feels really awkward and clunky at first until you realize that certain types of tasks, LLMs are fantastic at grading the response of other LLMs. And so you get this kind of new way of bringing engineering best practices adapted to this non deterministic, highly variable type of application.
Is it that when you are using one LLM to grade another, that the one doing the grading is like a larger model, has more parameters? Or is it that inherently LLMs are better at grading the work than they are of doing it originally?
Uh, their LLMs are just good at if you give them a specific task to solve. And so the LLMs that are in your application, they've been tasked to solve some problem that's serving the application needs. And they forget to kind of grade themselves, or they don't have the self checks or moderation in
Hmm.
place to make sure that quality is good. It's the same thing with a human. And like if you tell someone, check your answers before turning in your
Hmm.
submitting
Hmm.
your test, you likely will get better responses. And so if you also have a check with an LLM to have a be a bar raiser for responses, you get better results. And so there's lots of testing that's involved both inline, so at runtime, before you respond to the end user, check, make sure you're not making a mistake. And then there's a lot of testing that happens after the fact where you're trying to collect information around how well am I doing.
Okay, so let's get into the meat of what people are building with this stuff, and I want to get to like the kind of functional layer too. But first, like I think that frequently when you look at LangChain applications, they can be visually represented as a series of nodes and connections. And in traditional data processing, most graphs are acyclic. But I think in the LangChain graphs that I tend to see, cycles are allowed. Is
Yeah.
that like it? Are you fundamentally building a like kind of cyclic machine that all feeds off of itself?
Yeah, it's a new DAG where it's exactly that where DAGs, you go in one direction and they're very deterministic, and you can follow the logic of why each action is taken pretty logically. Um, when you're dealing with LLMs, the cool part is because they're non-deterministic. If you try a task the first time and you fail, trying the task a second time with the context of what didn't work the first time can result in better responses. And so you do have the ability to have cycles which often are like try again cycles. And a lot of times on second pass, with context of what didn't work the first time, uh, you can get a better result. Uh, you can also get endless cycles, and you have to deal with that problem as well, where you end up in these iteration loops that don't complete. But designing your graph in such a way where you have flexibility, so that you've given the LLM room to do its work, to reason about how to solve the problem without having a completely unbounded space, is kind of the hard part of constructing the graph.
I interviewed Yohei Nakajima from Baby AGI, he was the creator of Baby AGI, and he talked about an agent that he built that I think the prompt was something like create a business, like start a business, and it decomposed the steps needed to do that, and then it decomposed those steps, and then it started doing the thing, and blah blah blah, and you could actually just leave it running
Mhm.
for some kind of arbitrarily long time. When people build applications with LangChain, are they generally trying to build things where like there's a request response interaction, or is it like I'm going to build an agent that's like behind the scenes and it's just out there doing things?
I think there's a reality of like where the industry or what the technology can do today versus what we want it to eventually do, or what people talk about as like very exciting. So majority of use cases in LinkedIn, just because of where people are, tend to be chat applications and RAG, as we discussed. What you're describing is what we call agentic applications, where people have different definitions for it. Some people have the definition of agents are LLM apps that take action on your behalf, so things get automated. Our definition is more that you use the LLM to decide which steps to take. And so, in this example here of like build me a business, I didn't have to predefine all of the steps of first incorporate, then hire your employees, then you let the LLM decide basically the routes to take, and you can let it run. Both of those worlds are hard, as you can imagine. I don't think the business that this LLM built was going to be very successful.
No, no.
And so what we've been trying to do is with LangGraph is find a nice balance where you give the LLM the ability to route and make decisions, but if you fall into certain states, we define it in code which actions you're allowed to take. And so that's where the kind of conditional edges come into place, and you describe workflows in advance. And so what people end up building with LangGraph, they fall into a few categories. There's like concierge search, so a new type of way to discover information. Instead of clicking on a bunch of filters or just a normal search, you can chat and have the experience of, I'd like to go on a cruise with my family of 10. Can you send me some options? And it will go and give you a new discovery experience, so new user experience. A lot of co-pilots, so natively built into your application, where it's you can imagine lots of co-pilots as you're doing your DBT work to assist you as you're taking tasks, doing tasks, and then like operational efficiency things. So things that are repetitive or very time consuming. How do I automate that with an LLM, like extraction, summarization, research?
Are you finding, anytime there's new technology, it tends to be adopted first by a cohort of folks who often work at small companies and often very digital native oriented companies. There has been a tremendous amount of attention in the enterprise of the entire AI trend. I am not clear if the enterprise is AI curious or is really like putting applications in production. Do you have any insight into the relative stages of like digital native versus traditional enterprise?
Yeah, I mean, we've seen a lot of activity in the enterprise. As digital native, maybe not surprising, they're building things, but on the enterprise side, um, a lot of investment. They usually start with an internal application. So the first thing that people will build is productivity for their employees. And interestingly, we've seen for really large organizations, there's not only a mandate for their employees to get trained and learn about AI, and it could be as simple as just like prompting. How do you interact with an LLM? So, as an example, like Rakuten, which is one of our customers, they've built an internal GPT where all of their employees can build mini apps. And the most common app that people built or use at Rakuten is just practicing their English. And so we see that really frequently, that now mandated from the top. It's like everyone has access to uh, pick like your SSO. Everyone has access to Word, these like main applications, and then everyone has access to some internal chat app, which is generative AI, so people can learn to prompt it and to get their work done faster.
Okay, this is dicey territory. So you tell me what you want
I
to
was,
and
I was
what you don't
waiting. I
want to
was
talk
waiting for
about.
the.
Yeah.
these are softballs.
Well, I'm very curious about the like industry structure of the AI space. So, I'm largely an outsider here, but have some data points on like how these things are evolving. It feels to me like the cloud data space evolved in the way that it did almost completely because there was a standard to unite around, which is SQL. And then you could have all these tools that all interacted via this SQL interface and they could all be kind of best of breed. And okay, the modern data stack maybe isn't the dominant force taking over the world that it was in 2022, but largely that's because it has won and this approach has been pretty successful. In AI, though, it's not clear to me like where the battle lines are. You've got some of the things that you were talking about just now in terms of the, applications that Rakuten has built internally. My understanding is that OpenAI wants to service some of that stuff just like directly. Like they're building a lot of the tooling to enable people to just like not have third party tooling at all. You just like go straight to them. Anyway, do you have beliefs about like what the emerging categories are and how the lines are being drawn?
It's a good question. Obviously, the model layer is the one that
Sure.
there's like tremendous amount of interest, and you're not an LLM application without an LLM, and so it's the one part of the stack that you don't get to avoid. So lots of people are spending time there. Um, I think there's a big question about whether there'll be a lot of um, value accrues to the application layer or to the picks and shovels layer. And so picks and shovels would be, certainly LangChain is one of them. We're an orchestrator. We do testing and observability. We build tools for developers to build end applications, vector databases, model layer, uh, embedding models. There's categories that are just providing the tools, and then there's the application layer, which you see a tremendous amount of interest in. These are AI SDRs or AI marketing assistants. Customer support is an enormous category. And these companies are doing really, really well overnight. And, as a former investor, you'll hear some of the numbers of they did, went from 0 to 20 million ARR in 1 year, and you're just like, oh my gosh, how is this? They're like printing money, and so it's an open question of like where all the value will accrue or how sustainable either of those revenue streams are. But I think you always will have both. You'll have normally a fewer on the like picks and shovel side that accrue a ton of value, and a lot of people will try to go after that to be the oil or currency of the new industry. And then you'll have many, many more successes with the application layer. Um, and I think you'll have companies that will rise and fall pretty quickly there.
Join data practitioners and data leaders this October in Las Vegas at Coalesce, the analytics engineering conference hosted by DBT Labs. It's built by data people for data people. Register now at coalesce.getdbt.com. Listeners of the show can use the code podcast20 for a 20% discount. We'll see you at Coalesce.
If you just talk about the picks and shovels layer for a second, one of the criticisms of the modern data stack has been that if you want all of the appropriate picks and shovels, you have to go to like 12 different hardware stores to buy them all. And I think that there are players in the AI space that are a little bit more narrowly scoped than the stuff that you folks are building. But my understanding is that LangSmith is really kind of an end-to-end platform. Like, yeah, I think that your goal is to provide like all of the tooling required to put applications in production. Is that right?
Yeah, I think it's part of our philosophy is that the friction of the handoff, like the data is so important that you collect in production to help you improve your application that it needs to be all in one. And just to like maybe put a finer point on that, it's really hard to come up with realistic examples or edge cases that fail that you need to test against to improve your application. And so it's important to be able to observe production traffic, understand where your app is falling short, collect those examples of where you need to improve, and then feed that back in to your testing and design process so you can iterate faster. And so all in one makes a lot of sense to us. And the other cool thing that we're starting to invest in and experiment more with is can feedback from production use cases. So people liked your responses, or you got thumbs up, or people said this is a good response. Can we use that to influence and improve your prompting strategy, or improve the way that you actually can design your application? And so all in one is our approach. Certainly some people are more narrowly scoped, and they do testing for financial data really, really well, or they provide an LLM that's really good at SQL or data analytics. And so it's just where people are kind of picking their lanes. But we have aspirations to support you throughout your entire development lifecycle.
Got it. One of the interesting parts of the stack that I've talked to a bunch of folks about before is model routing. Is that just a component of a LangChain flow? Like there's a decision-making point in there, and does the framework make that decision, or can you plug in like external like model routers?
Yeah, I think that should just be in your application logic that you
Yeah.
code up. And so, like a very common, we call them cognitive architectures, which is like how do you break down the problem space into a logical flow? And it's very common for a flow to be you get a request, and the first step is you have a agent that routes to more specialized work tasks, and that in our point of view would just be code that you designed into the logic of your lane graph application.
I love this idea of, you said cognitive architectures. Is that what you said?
Mhm.
Yeah. Okay. Is a thing I've been thinking about a lot recently, and but in my own naive way, and so maybe you can enlighten me. The practice of design, and there's all kinds of design, but I think in the software industry, when we say design, we all kind of understand that like you're talking about humans who interact with users, really deeply understand what they want, and then build visual systems that allow them to interact. So we all have built this idea of like design, like what does good design look like over the last, I don't know, certainly 25 or 30 years of the internet, but then 15 years of the mobile era. And we just don't know a lot about what quote unquote good design looks like for these systems yet. Like, are there people who consider themselves like quote unquote AI designers? And what does that mean?
Yeah, I think people are trying to. Like, we work with IDEO, and they have a practice around like user experience for AI applications, and they're the only ones that they know of that spend a lot of time thinking about it. But I'm sure there will be more. But yeah, there's two types of interesting um, design that's happening. There's the user experience. So like, how does an end user interact with this application? Oftentimes it's chat, and you can think about how often you chat your software, maybe like 2 years ago, 3 years ago versus now. Hopefully that's starting to grow and will continue to grow, but it's a different interaction pattern than most people are used to. I use the example prior around um, discovery of booking a cruise. We have companies that are shopping online where you're now chatting instead of browsing. So it's a totally new user interface. There are other more like creative user experiences that we're seeing as well that are like ambient, where there's just an agent like listening and observing and then knows to take action. Maybe Alexa is like a good user experience pattern that people are familiar with. How do we build for that? There are research type user experiences that are done on batch, where maybe every morning they'll go off and do their homework, come back with a summary, or have taken some action on your behalf. So it's more background jobs to be done. But like as you start to dissect and think about the different types of user experiences that are now possible, or how do we design for them, it's a totally new world that I think I took for granted when Harrison thinks about it a ton. So it is these like small new ways to interact with your application and software.
I found myself thinking about this in the run up to Snowflake Summit. We released a native app, and it had a feature in it called Ask DBT, and you could it was powered by it is powered by the DBT semantic layer, and you can ask natural language questions, and it compiles them into semantic layer requests, and it gives you like governed answers back in text. But the interesting thing was not the user interface layer that you're talking about, because we were fundamentally trying to build a thing that felt kind of natural, that like relative to other AI experiences that people have had. Like, okay, chat's easy, it's good. The user experience that we were trying to think about was, what types of questions will people ask? And that is so different than the design process of saying like, well, here's the things that our application does, and here's an effective way to organize them in a UI. When you all of a sudden realize that your users could type in like literally anything, and then you have to choose how to respond to those questions, it really changes the game.
Yeah. I think that's the like second design pattern that I was maybe going to go into, which is your application logic has to reflect often how are people going to use your app. And so if they're coming in with certain types of problems that they need to get solved, you're going to design your app in a different way. Maybe we talked about like the hierarchy of routing. Maybe that doesn't make sense at all, because people come to your app for a very specific task, and so a hierarchy of agents is not the appropriate way to design it. A lot of times, people will work in a chat pattern, and when people have conversation, they append their thoughts or they correct their thoughts frequently. So it's like, order me this burger. Oh, and add fries. Is add fries, should it be added on to the original task, or is that like a whole separate task? Oh, just kidding. Actually, I want a salad. Now I have to cancel my prior request. And so thinking about like a real world interaction and then designing your app to update logic or append logic, or cancel logic all in real time, because user expectations are low latency, and these this technology to perform well takes time. And so that's also, I think, why we're really excited about these like long running background tasks and more use cases where you can get the most of the technology, which often has a lot of that like self correction or self moderation that we talked about prior, but that takes time, and so it's not a good type of quality check for a chat or a fast, low latency interaction.
How much do you think the creativity being unlocked in the LangChain ecosystem is still modest relative to what will happen with the next 1, 2, 3 major innovations in the underlying model architecture? Like, are we seeing the thing, or are we just seeing like a tiny little precursor to the thing?
Yeah, I mean, it has to be the latter. Even I've been in this space now for a year and change, and so the types of applications people are building today versus last year are very different.
Because the models have gotten better, or because people have gotten better at using them?
I think skill set mostly.
Hmm.
People have figured out. They've gotten more of the basics done. They've figured out how to kind of push the technology further. Like, yes, the models are getting better as well, and that helps. But I think as people learn what are the best practices for prompting, for fine tuning, for testing, we can just go a lot further.
Okay, I'm going to ask you one. This is a total speculation question, and then I'm going to end with the question that you authored originally on the podcast.
Oh God,
to wrap. But it's a speculation question. There was, I don't know, it was maybe in July. There was this back and forth series of Substacks. I'm going to totally fail to remember the authors' names, but they like widely read Substacks, where I think the main one was this like very optimistic take, where it mapped out like several orders of magnitude of improvement that we still have to go, and it showed the ways that model performance has improved with various or with all the orders of magnitude of progress we've made so far, and said like, look, this is how we get to AGI, and it's actually not that far away. It's in like freaking 2027 and whatever. And then there's the like naysayer take, and then there's the kind of modest take in the middle. You're a reasonably pragmatic person. You're not primarily an engineer. I think that you have like a lot of finance bones, and you can't actually be too much of an optimist if you are a finance person, because you won't get very far. What's your kind of like gut reaction on like the next 3-4 years and how this will play out?
You mean specifically like
Like,
how's
are
our
you
work going to
the extreme
change?
optimist? Are you
Yeah.
the extreme pessimist? Are you in the middle? Where do you sit?
Oh, I mean, you teed me up for being somewhat in the middle, but it's like I very frequently throughout my week will have moments where I'm like, holy smokes, this is very cool. Like my mind's blown. And then I will also frequently have moments throughout my week where it's like, wow, this is really disappointing. Like, we're not there yet. And so what I think we're definitely moving pretty quickly in a more positive direction. And the types of apps that I'm seeing built today versus last year are like a step function change better, but it's going to take time. And in terms of things that excite me, it's like really creative applications where you like couldn't do this type of work prior, and you have these like magical moments in an app experience that makes your life a lot easier, or something that would take a really long time, it's just done. Like, I don't know if I'm not a software engineer, but every time I can like generate Python, like that's awesome. I can just describe it, and I now have code that works. It works surprisingly well. I'm very excited about those types of things, but I'm also realistic in that we're figuring everything out as we go, and this build me a business prompt is this for decades from that.
Decades.
Yeah, for a full total.
AGI is not coming before 2030 is my takeaway from that.
Yeah, that I'm on record.
Okay, great. Yeah, I both feel deeply skeptical that things will move at quite that pace, but also I have been surprised to date at the speed with which some things. So I have some epistemic humility. I think the thing that I fundamentally don't believe is that I don't think it's going to be as disruptive in a negative way as people
Oh yeah, that
sometimes are concerned
I'm
about.
yeah, emphatically with you on that. Where humans are very resilient throughout all technological step function changes, and we find other ways to be productive and work alongside our technology. And I think that will be just the same in this evolution.
Okay, so we're in the zoomed out space. Tell me, rather than prognosticating what will be true, tell me what you hope will be true over the coming 5 years in AI.
I think one of the things I'd be very excited about is that ambient use case where I have a personal assistant that knows the type of work that I do and can help um, kind of work alongside me, and without my even prompting or asking, have good insights in either how I do my day-to-day work. And my assistant will maybe look very different than your assistant because we do different things. And I see like some people working on personal assistants, agents, co-pilots, and um, things that are like tedious or tough or frustrating just become easier because we all have a little bit more support.
Do you have an agent that responds to your emails yet?
So, uh, if you message our CEO, you will get an
I know
agent.
he
Yeah.
warned me. He said that he
Which
babysits the responses though.
Yeah, we do human in the loop, and same thing with our customer support. All of it runs
Hmm.
through a bot we built, and it's pretty cool. We call it Carl, based in because we're based in San Francisco. Carl, the fog. But all of our support requests come in, takes a first pass. It first thinks people and summarizes what the request is, and then
Does it
routes it to
declare that it's
people.
an agent?
Nope, nope.
Hmm.
Just LangChain support. And so it's been kind of cool for us to dog food our own technology and
Hmm.
learn about the user experience handoffs, because it does some things very well, and some things it can't do. And so knowing when to have an auto response versus phone in for help is an interesting design challenge too.
Julia, thanks so much. It's been fun to check in, get a little bit of a view into your world.
Tristan, good to be back. This was fun.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.